My name is Addison Wilson, and in this video, me and my group will be performing the copperamine synthesis lab. To begin this experiment, we need to create a stock. To first make the stock, we need to measure out copper sulfate pentahydrate. We got about 0.087 grams, and we transfer that into a volumeric flask. We then dissolve it with water, and that creates the complex ion of hexaalpha copper. We then add concentrated aqueous ammonia to the dissolved copper, and upon first reaction, it will make copper hydroxide, which is insoluble. But in the presence of more ammonia, it then makes the complex ion copperamine. We cover up the ammonia to make sure the fumes do not escape. We record the data, and then we further dilute the solution with water. And since it's in the volumeric flask, the line represents 25 milliliters. And this will be the volume of our stock. One thing you do not do when you are using a volumeric flask is you go above that line. As you see that we did, the meniscus was above the 25 line. And if you go above, that means the solution in your volumeric flask is incorrect and you must restart, which we did. So after we made our stock, we then begin to make our series of dilutions. To make a dilution, you take a small portion of your stock, and then you add water to match the total volume of your stock before you drew the volume, which would in our case would be 25. And we decided to take 10 milliliters of the stock to make this dilution. Here we are adding the drawn solution to a volumeric flask to make sure that we accurately have 25 milliliters to make our first dilution. An important equation to keep in mind when you are performing the dilution is M1A1 equals M2V2. M stands for molarity and V stands for volume. Your M1 is going to be your solution, and your M2 is going to be your first dilution. Here we drew 10 milliliters of our stock, which would be our M1 of V1, and then we ended it with 25. As you can see, we have a very clear dilution, a color change, and that indicates a very successful dilution. We then perform our second dilution. As you can see, we are pouring only 10 milliliters of our first dilution to make our second dilution. It is very important that you consistently take the same number of drawn volume, or V1, and ending volume, or V2. If you do, you will have a hard time calculating your unknown molarity of your dilution. We then begin our third dilution. Now, the reason why we are making 3 dilutions is more important to the second half of this experiment, which will not be shown in this video. We will be sending these solutions through a spectrophotometer, which will read the absorbency of light through these liquids. Now, the absorbency is very proportional to the concentration of your dilution.